So for this reason, it's not a matter of just one or two or three developed countries. It's really a worldwide issue. And you know very well the progress according to the climate change, the glass, water lack, flu, and then the reaction of all the nations were several summits, and the last one was in Paris 2 months ago. So the situation now is a worldwide issue and worldwide concern and worldwide commitment. So the sustainability has two levers. The first one is the dark side of large consumption products. We have a lot of products, so we have to think about impact, environment, safety, health, and I just give you a few based, chemically based on. It's they are very common cells, medicine, medical waste, etc. All are produced every day, and all have strong impact. If we look just the heavy metals, all the very common products, even the key, is based on chromium and nickel, heavy metals. So every product here, even the paint has metal pigment. So all the common products are based, the lamp, the neon, electronic, and we continue, screen, fridge, washing machine. This is a good example for the mobile phone. You have all one or two in the pocket. There is 30% of cobalt inside, carcinogenic. But $45,000 per ton, the price of the cobalt, with the light side and the dark side. And then all those metals, each one has his specificity. Like you like fish or chicken or salad. Some like the knee, some like the head, some like the liver. Each one has an impact. There is now even the sodium, which is needed for the life. If you take a lot of sodium, you have overpressure. So every metal of the periodic table has his backside, dark side. Sorry. The second level is the availability of geopolitics, because we have only one planet. We eat a lot for 100 or 200 years, and now the situation becomes critical. For instance, if we look to the very common metal, some metals we have only for 30 years, 20 years, some 17. For the tin and the silver is very interesting. When we start the Convention of Montreal, and producers decide that they make lead-free electronics, it's a very good initiative, excellent. And then the reaction of the engineers, because engineers in the middle there is genius, they react very fast, and they said, okay, now lead, we will find. And they find a paste with tin and silver, and then electronic increase, and tin and silver decrease. And without recycling today, we have a lot of trouble. And it is the case with zinc, with copper, with indium, for instance, or flat screen. Then, if we continue to this with this appetite, only iron we have 400 years. This means that we come back to the Iron Age, and probably we survive, because they survive also from the Iron Age. But no more mobile phone, no more Facebook. So it could be for someone of you, it's a nightmare. So the situation in the mine strategic metal is that there is now a unit here, it's just ratio between the autonomy and the vulnerability. So it's a conversion of the previous slide. You see you have low vulnerability, high autonomy of iron, but there is some metals in a very critical situation if we don't make any recycling today. And finally, the cobalt, for instance, which is the base of mobile phone batteries, it's in very critical situation. And the geopolitical, in not only on the availability, but also on the geographic distribution. I mentioned a few metals, like rhenium, 67% owned of the resource, of the worldwide resource, owned by United States. Niobium, 90%. Without niobium, now magnet. 90% of the known resource and economically recoverable is in Brazil, are in Brazil. So it's a big problem. Copper, tungsten, rare earth in China, palladium in Russia, platinum and cobalt in Africa, in West Africa, just between Zaire, Zambia, and South Africa. They own 70% of platinum and 45% of the cobalt. Tantalum too. And I will come back to the lithium, but the lithium today is a big issue because 75% of the production is owned by 2 countries, and 81% of the known deposits are owned by 3 countries, and the biggest is Bolivia, which don't start yet production of lithium. They produce only of basic carbonate or chloride, and then already 81% owned by 3 countries. Europe, and also Singapore, and also Korea, and also Japan, has 400 kg of waste per year and per habitant. So there is now a strategic resource, but all those waste, all those strategic metals are in the waste. This means that in front of US, who has 67%, or in front of China, 80% of the tungsten, Europe has, and Singapore, Taiwan, and Korea, and Japan own also a strategic stockpile of waste containing all the strategic metals. This means that they have to manage this for the future as a resource and not only as fatal waste. The increase of the product definitively decrease the resource, but if we look each one, if we continue to eat a lot of non-rechargeable batteries, one day we decrease definitively the zinc and the manganese. If we eat a lot of, and we consume a lot of flat screen with 2 years, 5 years, 4 years life cycle, then we completely decrease the resource of indium. This means that today we have only one solution, is to shift from the old mine, for the product of the city, to the urban mine, which means that you consider the waste and the product not as own product, but as metal resource. For instance, here is a resource of rare earth and barium. This is a resource of precious metals. This is a resource of cobalt. So we have, this is iron mine. And then this is cobalt mine. And then if we move to urban mine, then the sustainability of the city is to organize the end of life, the collection, the reuse, for the recycling of every waste coming out from the city. And now I'm speaking only on the metals. Beside the metals, you can apply this system to the organic and to other kind of waste in the city.